We'll now learn the basic proportionality theorem. So we have a triangle ABC. So we are given triangle ABC and we have a line segment that is parallel MN is parallel to BC. Then by BPT we can say AM over MB. We can say AM over MB is equal to AN over NC. This is called the BPT, Basic Proportionality Theorem. We can also use it in other ways, like we have PQR. And here if we have XY parallel to PQ, so now we can write PX over XQ. So it is RX over XQ will be equal to RY over YP. Here again, if we have another triangle, say we name this ABCD, and we have here a line that is parallel, say PQ is parallel to AB. Now we can write CP over PA is equal to CQ over QB. So this is the BPT. Here we'll see what are similar triangles. If I say triangle ABC is similar to triangle PQR, similar. What does it mean? That all the corresponding angles are equal. Angle A equal to angle P. So this is angle A will be equal to angle P. Then B equal to Q, angle B equal to angle Q, and angle C will be equal to angle R. So angle C equal to angle R. All the angles are equal, the corresponding angles are equal, and the sides are proportional. Sides are proportional. So by saying sides are proportional means AB over PQ will be equal to BC over QR will be equal to AC over PR, which means sides are proportional. Now we'll go to the test of similarity. The first test is called the AAA test, or it can be also said as the AA test. And from this you can make out A means angle. So if I can show two angles like A equal to Q, and if B is equal to R, if two angles are equal, I can say the triangles are similar. So while writing the similarity, if I write A here, I have to write Q because A equal to Q. Then if I write B here, I need to write R. Hence, I can say now C must be equal to P. So this C will be equal to P. So the triangles are now similar. So we can say triangle ABC similar to triangle QRP by AAA test. And to write the proportionality, we will write AB over QR will be equal to BC over RP will be equal to AC over QP. All the angles are equal, the sides are proportional. So this was the AA test. Now next we go for the SAS test, which means we need to show two sides and one angle. So for this I will say side AB over PQ. So I have AB over PQ say is equal to BC over QR, and the angle that is included should be equal. So B should be equal to Q. So angle B equal to angle Q. So I can say now the triangles are similar. Triangle ABC similar to triangle PQR by SAS test. Now remember, it should be angle Q. If I have angle R equal, if B equal to R, it does not work, because remember R is not the included angle. The included angle is Q. So B should be equal to Q. So by SAS test the triangles are similar. So here is triangle ABC, and I have a line that is parallel. So I put PQ. When you see a figure of this type, you can use two properties. One, you can use the BPT. So we'll write AP over PB will be equal to AQ over QC. So one is BPT is AP over PB equal to AQ over QC. But in the same figure, this is property 1 or BPT. In the same figure, I can see two similar triangles. Here we know angle P will be equal to angle B, corresponding angles, and Q will be equal to C. So we have angle P equal to angle B and angle Q equal to angle C. So if you consider these two triangles, here if you consider APQ, you can see two triangles here, APQ, and the other triangle is ABC. They are similar. So triangle APQ is similar to triangle ABC by AA test. Therefore I can write AP over AB equal to PQ over BC equal to AQ over AC. So when you see a figure of this kind, two properties come to your mind. One property is a BPT and other of two similar triangles. Let's go over it again. So when you have this figure where the lines are parallel, first property that comes to your mind is BPT, that is AP over PB. Here AP over PB equal to AQ over QC. And then again in the same figure, you can see two triangles. One triangle is APQ, the small triangle, and the larger triangle is ABC. And these triangles are similar. Why? These two angles are equal, corresponding angles, and here again these two angles are equal by corresponding angles. So we can say triangle APQ similar to triangle ABC. And however, you know A is common. So we can write now AP over AB, corresponding sides are proportional, equal to PQ over BC equal to AQ over AC. In this sum, we have two triangles that are similar. LMN is similar to PQR. So triangle LMN similar to triangle PQR. And if they are similar, their angles are equal. So I can say here angle L will be equal to P. Here L will be equal to P. Then we have M will be equal to Q. So M to Q. So let's mark the angles. They gave angle L as 60 here. So we will write 60. M is 50. So by angle sum property, we know in triangle LMN there are three angles equal to 180. So 60, 50, and the angle N we do not know. So we'll find angle N. So N will be 70. So this angle here is 70. And you know this angle N has to be equal to R, because N is equal to R. So your R will also be 70. So this was your first step. In your second step, you'll say angle N equal to angle R. Therefore, angle R equal to 70. Corresponding angles of similar triangles. For the next sum, the similarity is given to us. Triangle AHK is similar to triangle ABC. Hence, the sides will be proportional. So we can say AH over AB will be now equal to these two. That is HK over BC will be equal to AK over AC. AK over AC. We put the values. AK was given as 10, BC 3.5, HK 7. We have to find AC. We put AC as X. So we put our values. AH and AB is not given, so we don't need this. So HK we see was 7 here, BC was 3.5, AK 10, and AC X. So 7x equal to 10 into 3.5. So X 10 into 3.5 over 7. So X will be 10 over 2, X will be 5. So AC is X and it is 5 centimeter. For the next one, MN is parallel to AC. So we have MN parallel to AB. So in triangle CAB, MN is parallel to AB. So hence we can write CM over MA equal to CN over NB. So write that CM over MA equal to CN over NB, BPT. Now the values are given to us. Here AM is given as 4, so this is 4 centimeter. Then MC is 2 centimeter. However, in the next case, BC, the entire BC is given as 7.5. So hence I'm going to take NC as X. If NC is X, therefore I can say BN will be 7.5 minus X. So BN 7.5 minus X. MC is given as 2. AM is given as 4. So let's put our values now. CM is 2. MA is 4. CN I have taken as X. And NB I have taken as 7.5 minus X. This is by BPT. So let's cross multiply. 4x. Here we get 30 minus 2x equal to 4x. So 30 equal to 4x plus 2x. 30 is 6x. 30 over 6. So x equal to 5. Here AB is parallel to DE and BD is parallel to EF. We need to prove this. So first we'll take up the triangle CAB. So we write down triangle CAB, and we have the parallel side. We have DE parallel to AB. So we will use BPT. To use BPT, we know it will be what? CD over DA will be equal to CE over EB. So DE parallel to AB, therefore I can write CD over DA equal to CE over EB, and this is by BPT. I will take up the other parallel lines. We take up CDB, the triangle CDB. Here C, D and B. Here we have another set of parallel lines, that is FE is parallel, FE parallel to DB. So in triangle CDB, FE parallel to DB, which means now that CF over FD equal to CE over EB. So we write CF over FD equal to CE over EB, BPT. This is equation 2. Here I will put equation 1. Now look very carefully at the equations, and you see this is common. There is CE over EB here, there is CE over EB here. So when I compare both, I can say from 1 and 2, I can say CD over DA must be equal to CF over FD. Let's change the sum a little bit. So we need to prove CD over DA equal to CF over FD. So when I put them together, you have FD and we have proved here, right? But the same sum can be given in another way, which I'll be doing next. Now the same sum can be asked in another way. We have to prove here DC square equal to CF into AC. And we take the same triangles, ACAB. Here is a line that is parallel. Now if you notice, you can see two triangles here. One is triangle CDE and triangle CAB, the bigger triangle. And both these triangles are similar. Why? Angle D equal to angle A, corresponding angles, and we have E equal to B, corresponding angles. So the two triangles are similar by AA test. So we need to write that. So angle CDE equal to angle DAB, and angle CED equal to angle EBA, and this is by corresponding angles. So triangle CDE similar to triangle CAB, which means that CD over CA, so CD over CA will be equal to DE over AB. We'll put this as equation 1. Now we'll take up the next triangle, that is CDB. We'll put it in green. So we have CDB, And in CDB we have this line that is parallel. So here we have two triangles again. We have triangle CFE and triangle CDB. These two triangles are also similar. F equal to D, corresponding angles, and we have E equal to B, also corresponding angles. So two angles are equal, the triangles are similar. CFE will be equal to CDB, and here CEF will be equal to angle CBD, and this is also corresponding angles. So triangle CFE similar to triangle CDB. So let's write the corresponding sides. So we have CF over CD equal to FE. We won't need FE, so we will just take, here we'll take CE over BC. So this becomes equation 2. Now when we compare equation 1 and equation 2, here we need to make a little change. We need DE and DE we require, here we require CE and CB. Now when we compare, we get this common, C over CB equal to C over CB. So I can now say from 1 and 2, CD over CA equal to CF over CD. I cross multiply, so I get CD equal to CF into CA. So CD square equal to CF into CA. We have proved. You would have noticed by using different properties we can prove different results. In the earlier sum we use BPT. In this we use two triangles are similar. So here in the sum we have a triangle ABC, right angled at C. So this is C, which is a right angle, 90. And we'll write here ACB. P and Q are two sides. P and Q are points on CA and CB. That means P is on CA. So we put P here. And Q is out here. We'll now join PB and AQ. In this figure we can see four right angle triangles. First one is ACB. So we take up triangle ACB and use Pythagoras theorem. The hypotenuse here is AB, so AB square equal to AC square plus BC square. Next we'll take the triangle ACQ, and in ACQ we will use Pythagoras theorem. So triangle ACQ, we have AQ square equal to AC square plus CQ square. Next we can see yet another triangle, and that is PCB. So in triangle PCB, hypotenuse is PB, so PB square equal to PC square plus CB square, equation 3. And then we have the triangle PCQ, this triangle. Here again we use Pythagoras theorem. In triangle PCQ, PQ square equal to PC square, CQ square. This is equation 4. If you look up here, we need AQ square plus BP square. So we are going to add here, or to get AQ, we need AQ square. So we need to add AQ square and then we need to add PB square. So we need to add 2 and 3. So 2 plus 3. Now the equation 2 is AQ square equal to AC square plus CQ square. And look up at equation 3. Equation 3 is PB square equal to PC square plus BC square. So when we add up, we have AQ square plus PB square equal to AC. We are adding up both the equations. PC square plus BC square. But look up very carefully and see what is AC square plus BC square. Look up here. AC square plus BC square is AB square. So we will put AC square and BC square together. AC square and BC square together. And then we will put CQ square and PC square together. CQ square, PC square together. And we see that AC plus BC square is AB square. And on the other end, CQ square plus PC square, if you look up here, CQ plus PC equal to PQ square. So we have proved what they've asked us for. They asked us to prove AQ square plus BP square equal to AB square plus PQ square, and that is proved. Yeah, just to go over it, here we remember we did for AC square plus BC square, we got here AC plus BC here, equation 1. This came from equation 1, and this came from equation 4. PQ equal to 24, so this is 24 centimeters. QR equal to 26. PA equal to 6 and AR equal to 8. Find QPR. So first we'll take up the triangle APR. Now in the triangle APR, here is given 90 degrees. Angle A equal to 90. So we can use Pythagoras. PR square equal to AP square plus AR square. PR square we don't know. AP square is 6 square. AR square is 8 square. So PR square equal to 36 plus 64. So PR square equal to 100. PR will be under root of 100. So PR will be 10 centimeter. So we've now found out that this is 10 centimeter. Now let's take up the triangle PQR. In the triangle PQR, the angles are not given, but we've given all the three sides. PQ equal to 24, which means PQ square equal to 24 square, which is 576. Then it's given to us QR equal to 26. So QR square is 26 square, which is 676. And we found out PR. PR we found out is 10. So PR square equal to 10 square, which is 100. Now if you look very carefully, you would have noticed that 576 plus 100, 576 plus 100 equal to 676, and 576 is PQ square, 100 is PR square, and 676 is QR square. So by converse of Pythagoras theorem, we can say QR must be the hypotenuse. So if we draw the triangle like this, QR is the hypotenuse. This angle here, angle P, must be 90 degrees. So angle QPR equal to 90 degrees by converse of Pythagoras theorem. Here in the next sum, we have the triangle ABC. Then they have given here PQ are points on AB and AC. So I will take P here and Q here, such that AP is 3.5. AP is 3.5. PB is given as 7. AQ is given as 3. And QC is given as 6. So we join this. And we need to find if PQ is 4.5. PQ is 4.5. We need to find BC. So BC is X. In the first step, we notice here no parallel lines are given. So we got to prove that PQ is, we need to prove PQ parallel to BC. It's not given to us. We need to prove it. How do we go about proving it? Look at AP. What is AP? Look up and see. AP is 3.5. Then what is PB? How much is PB? 7. So what is AP over PB? 3.5 over 7, which is 1 by 2. Then next see what is AQ. This is AQ. 3. And look at QC. QC 6. So AQ over QC is 3 by 6. That is also 1 by 2. So AP over PB equal to AQ over QC. Therefore, by converse of BPT, I can say PB is parallel to BC. I mean PQ is parallel to BC. Reason converse of BPT. Now for the next part of the sum. Here we can see two triangles, and the two triangles is with the small triangle APQ and the bigger triangle ABC. And look carefully, the two triangles are similar. We know these two angles are equal, corresponding angles. We'll put it in blue. These two are equal, corresponding. And then we have these two are equal, also corresponding angles. So the triangles are congruent by AA test. So triangle APQ similar to triangle ABC by AA test. Of course, you've got to write the angles. Now if the triangles are similar, the corresponding angles, the corresponding sides are proportional. So I will write AP over AB equal to PQ over BC. And let's put our values. Look up in the figure and see. So we have now AP over AB equal to PQ over BC. Look up in the figure and see what is AP. We see that AP is 3.5. So we put 3.5 here. Look up and see what is AB. AB is 3.5 plus 7 and AB is 10.5. Now what is PQ? PQ, if you see, look up in the figure, you'll see PQ is 3. No, PQ is not 3. PQ is 4.5 here. And BC is X, which we need to find. So then you go ahead and find the BC. Cross multiply 3.5x equal to 4.5 into 10.5. So your X will be 4.5 into 10.5 over 3.5. This sum is from exercise 6.5, question 14, page 151. Just look up at this video and you'll get the solution. ABC is a right angle triangle. Right angle at C. DE is perpendicular to AB. Prove that the triangles are similar. So in the first step, I'm going to first show the triangles are similar. So we have here triangle ADE, and then we have the larger triangle, this big triangle here, which is triangle ACB, and we have to show that they're similar. Now they have common, angle A is common, so angle A equal to angle A. Now next, if you see, this is 90, C is 90, and here E is 90. So here write angle E equal to angle C. So now you're left with the third angle. So we are done with A and E, and here we are done with A and C. Therefore we can now write that D must be equal to B. D will be equal to B. So angle D equal to angle B. So when we're writing our correspondence now, we'll write AED is similar to triangle ACB. That means AE over AC will be now equal to ED over CB, and will be equal to now AD over AB. In the next step, we're going to use Pythagoras Theorem. We'll now rub this out. We'll use Pythagoras Theorem in the big triangle. In triangle ACB, we will use Pythagoras Theorem here in ACB. So in triangle ACB, it means AB square equal to AC square plus BC square. So this is AB square. AC square is 3 plus 2, 5 square. BC square is given as 12 square. So AB square 25 plus 144. AB square equal to 169. So AB equal to 13. So this comes now 13. Now let's put up our values. So we see AE. Look up in the figure and see how much is AE. We do not know how much is AE. So we write AE here as it is. Look up and see AC. AC, if you see, is 5. 3 plus 2, 5. ED. ED is also not known. Look up and see how much is BC. BC is 12. Then look up and see how much is AD. AD is 3. And look up and see how much is AB. AB is 13. So we can find, now if we take up this ratio, we will get AE over 5 equal to ED over 12. Now in fact we can't get with that. So if you notice, we got to take up, if you notice, we couldn't get. So what we have to do, we have to take up this and this together. So we will take AE over 5, 3 over 13. So AE will be 3 into 5 over 13. Now to find out ED, we need to take this ratio and this ratio, because this is what we know. So we'll do ED over 12, 3 over 13. So ED will be 12 into 3 over 13, and that will be ED.